Okay, so theme 6, last theme, was correlation and regression. Okay, so correlation and regression is all to do with how do two variables relate to each other, okay? Now, there's two parts to it. The regression side, first of all, is basically coming up with a line of best fit, and it's a linear line of best fit, okay? So it's literally, I'm trying to estimate y given some sample data. I need to estimate the y-intercept, which is a, plus some gradient times by my x values, okay? And you've got formulas to work out what the a and b is. Isn't a, off the top of my head, y bar minus b times x bar? And b, I think, is sxy over sxx. Do you agree with that? Yeah. Okay. So make sure that you've got those formulas in the formula sheet and have a look at those as well. Honestly, main thing I'm going to ask you with regression side of things is, first of all, here's some sample data. Can you calculate my least squares regression line? Using that, can you estimate? So for example, I give you y and you need to find x, or I give you x and you need to find y. Make sense? Yeah. And then the other thing which I could ask you from this.
Like, to do this, we need the equation.
Good.
So we are going to calculate the equation to make estimation.
Exactly. So I would ask you to calculate the equation first. Then I give you some particular values and say, okay, using your equation, using your regression line, can you find the relevant thing?
What if they are out of the range?
Good question. That's my next thing. So if they're outside the range, we call them extrapolated. Yeah, I'll take that. If they're inside the range, they're called
interpolated.
Excellent. Interpolated. Okay, so yeah, so outside, inside. So that's it with regards to regression. Okay, so generally, like I say, there's very little I can ask about this. Okay, generally I say, look, here's some data, find me the least squares regression line. Okay, and then from this, using that least squares regression line, can you estimate values? Okay, and then comment on the reliability, and that's really where I'm asking about, can you understand the difference between an extrapolated value and an interpolated value? Okay, so if it lies outside the range of given data, it means that you are having to assume that this particular model continues outside the range of particular data, so it's generally less reliable. If it's inside the range of given data, it's interpolated, it means it's slightly more reliable. Okay, that's it for regression. So that's my regression. Looking at the correlation part, really only a couple of things that I can ask. Okay, first of all, can I ask you to calculate the correlation coefficient? So R. Okay, so just remember that is equal to sxy divided by square root of sxx times by syy. Again, formulas in formula sheet. What's the range of this particular value for my correlation coefficient?
0 and 1.
Nope.
-1 and 1.
Good. And clearly you understand values which are close to either -1 or 1 are strong correlation in either negative or positive direction, depending on the sign. Values which are close to 0 means what?
No, there is no correlation.
Not no correlation.
Is it 1?
Means 0 correlation. Right? There's a difference between no correlation and 0 correlation. No correlation means that there is no correlation, there's no relationship which exists between the two variables. May not necessarily true, because remember, this is x, and this is y, would give you 0 correlation. Okay? 0 correlation just means that according to this particular correlation coefficient, the value is 0. Doesn't mean there is no correlation between the two variables. Clearly in this case there is. Okay? So 0 correlation just means the value of R is 0. Remember that R is assuming that my two variables are related in a linear way. Okay?
So basically, if we find R as 0,
yes,
then it means there is no regression correlation.
There is no linear correlation.
Linear.
Good, exactly. So that's fine as well. If you wanted to put no linear correlation, that is totally fine with me. Or if you wanted to write zero correlation, that's also fine, on the basis that this R has a value of 0. That's what it means by that. Does not mean no correlation. If you put no correlation, you will get 0 in the exam, right?
If you say zero, no correlation, it's like it's not. There's no value attached to it. You're not between -1 and 1. You're not implying any relationship to anything. You know?
Yeah.
It's like you're comparing two things that have no relationship. It's like.
Yeah.
It's like there's 0 is actually more correlation than none.
Yes. Yeah, it's a really good way of thinking about it, actually. Yeah. Yeah. No, zero correlation is more correlation than no correlation. Yes. No, I know exactly what you mean. It's a really good way of thinking. It is. Yeah, because you're absolutely right. Correlation is a measure of how two variables are related to each other. It's literally what correlation means. Co means together. Relation means a relationship between two things, a connection. Okay. Yeah. Whereas if you say no correlation, it means there's no relation. Yeah, exactly. So you're fine to say no linear correlation, because linear correlation implies that there is a linear connection between the two variables. That's fine if you want to say that, but zero correlation is better because it's saying that in this case that the value is 0, okay, which has a specific meaning.